Yeah, all right. So today we'll be talking about networking in AWS. So it's like, let's say in your home, let's say you have Wi-Fi. It's your own network, right? So your laptop, or it can be, your phone. So everything will be, connected to your Wi-Fi. So that's your own network. So your device IP address and everything will be like that. I mean, according to your Wi-Fi address. So same thing in organizations also. We have our own networks in organization. Will be connecting our devices into that, our servers into that. Same way in AWS also, there is a concept called VPC, which means virtual private network or virtual private cloud we call it. So where we can able to create our own network in AWS, virtual private cloud. So we can able to create our own network in AWS, and we can able to run our services in that account, sorry, in that network. Why why we need to run, why we need to create in our own account? Currently we are creating everything, right? So there is no blockers. Of course there is no blockers for now, as of now. Without network also we can able to do anything in cloud. Why network? Because with our own network, the first thing is we have our own IP range, our own, we have, I mean, I don't want to go to introduction of IP ranges again. I think you know it. There are five IP ranges, IP classes from 0.0.0. to 255. So that's, they are divided into five IP ranges. So here, when we create our own network, means we'll be having our own IP range. So where our servers or whatever the infrastructure we are creating, load balancers and everything, will be running in our own range, network range, so that we can able to control of what's coming in the traffic and all. So let's say I created my network and running my load balancer in that, so I can control who needs to access it, who needs to block, and I have more clarity on what's happening. So that's why it's good to have your own network. So there are, I mean, in order to do that, I mean, in order to have this our own network, we have a concept called VPC. So this is the very first concept in cloud. I mean, because let's say if you create EC2, or let's say you create a load balancer, or let's say you create a lambda function, what else? So there are multiple maybe services which might, or let's say auto scaling. So we have lots of things, right? Or let's say EFS, or it can be, yeah, I think that's it as of now. So any of these services we can able to run in this network. All the services, I mean. So we control all these services. So we can manage everything with our own networks. So by default, in each and every region, there is one VPC available. See, I did not created this. So this VPC is available in each and every region. It's created by AWS. If you go to, let's say, something, maybe Mumbai, see, there is a VPC. Let's go to maybe Singapore. See, VPCs exist in every region. These are default VPC, we call it. So as of now, we have used the default VPC whenever we are creating services. So today we'll be creating our own VPC, and of course there are multiple components inside the VPC. We'll talk about all those concepts. What are those? Why it will be used? And yeah, we'll be seeing that. So before working on a VPC, we need to know about IP classes. IP classes. Let's go figure it out. Let's go here. IP classes ranges. So these are the classes. Even if you just now, if you open laptop or mobile, check your IP address, it will be in any of these range only, not more than this. So 255.255 is the last address. You don't see an IP address with 256. No, you don't see it, because this is IPv4 address, and from starting 0.0.2 to 55 address will be used. Got it? So here there is something called CADR block. CADR, it means, what does it mean? CADR is, see, you are creating a network, correct? So your network belongs to any of these classes, so you have to choose that. So let's say my most commonly we see is class C, 192.168.0.0 blah 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 something. So that's usually will be the IP address or something. I mean majorly, not default, majorly. So which classes belongs to class C? So like this, or let's say your IP is 10.10.10.10. Which class belongs to 10. Class A? Or IP address is 172. Let's see here. It is 172.31.0.0. So 172 where it will come? Class B. So like this, whatever the range you select, that will comes under any of these classes. Got it? So here what happens is like we also have to choose our own CIDR block. CIDR, classless inter-domain routing. So there will be a small calculation for that which we need to use. How is, let's say, so a CIDR block, how you do choose the CIDR block is, let's see, yeah, let's create a VPC. Simply just create a VPC. So for now just click on just VPC only, let's keep it like that. My VPC, simply just IPv4. See, it's asking CIDR block. So what do we have to give as an example? Let's see, it is showing this one 10.0.0.0/24, and if you see here, CIDR block size must be between /16 to /28. What are those /16/28? So yeah, sorry. So it's saying CIDR block size must be between /16/28. What are those /16? They are called subnet masks. So what does that mean is, subnet mask is to get your IP ranges. See, let's say you chosen one class, and how many IPs you want, maybe something, maybe 100 or 200 as an example I'm just saying. So in order to get the 100 IPs, you need to use a subnet mask. As an example, let's say, just an example I'll show you, 10.10.0.0/24. I used this one as an example. So what happens, /24 means there, it's a range subnet mask, so there will be a fixed number of IP addresses for those. So for example, /24 is 256 IPs. So like that there are multiple. /16, it seems /16 is around, I think, 65,000 IPs. /28 is there, right? /28 is 16 IPs, 16. So the formula is 2 power 32 minus n. 2 power 32 minus n. So like that you will be calculating this, and you will be deciding your CIDR block. So before going, creating our own, giving our own subnet CIDR blocks like that, so we have 4 columns in IP address. I'm not going deeper into networking, these subnetting concepts for now, but at least in order to create our own network, so we need these things, that's why. So there will be 4 columns. If you see 10.10.0.0, let's leave /24 for now. So these actually separated by dots. Each column represents 8 bits of data, which means totally 32 bits, right? Overall IPv4 address is total 32 bits. Let's take them as ABCD. So first column A represents the class of the IP address. So the first A column is represents the class 10. 10 dot, let's say 10. So 10 means class A, and the second column represents, it works with the first column to define the network, because 10 network means 10 network will be huge. So we are creating our own network. So let's, within the 10 range, what you want. So you know what we can give here, from 0 to 255 you can give any number. So which will which will be inside this 10 network, anything. Let's say you can, maybe let's give 255, just an example. You can give like this, or 251. It's fine, it's completely fine. Here what we're doing is, the first column is represents the IP address class A here. Second column works with the first column to define the network, and third and fourth column will be used for, third column will be used for subnetting. We'll see what is subnetting maybe next few minutes. So for now let's keep it 0. I'll tell you why later. And finally the fourth column will be for host. If you give some number here, let's say .1, this will become IP address. If you give 0 here, that will become a network network range. So for now we are creating a network, give it 0, and slash how many IP address you want. So usually I want everyone mostly creates with 16 network /16 subnet, which means the subnets will be 65,000 IP addresses. Sorry, the network will give you 65,000 IP address. Of course we don't be needing, we won't use that many, but why we'll creating, we'll see later. So that's about the IP address. Just a very basic, I'm just saying, not really that much. So here you may ask, I can use /24 also, but these subnet depends on the last two the digits. As I told you, let's say 10.10.10.10.10. This is IP address. If I give 0, this is a network, and in this 0 place I can get 0 to 255. It means I'll get 256 IPs. So what is the subnet range for this? It will be /24, because I'm getting 256 IPs, right? /24. Now let's say 10.0.0/16 I'll give. Here 65,000 IPs will get. You know how? Here 256. 10.10.1.0, 10.10.2.0, 10.10.3.0, like this 256. Again 10.10.10.1, 10.10.10.2, like this. If you calculate, it will come 65,000 IPs. So 65,000 means /16. How do I know /16? You have to calculate these things. These IPs calculate how many IPs you'll get. If you give some number here, that's a range. Sorry, if you give 0, that's a range. If you give a number, let's say any number randomly, that's an IP address. Let's say I give a number here, it's an IP address. So 0 range 8, it's an IP address. If I give 0, it's a network. How do I know 16? Calculate it, and of course we'll by head it. It's like a blind remembering it. That also one thing. So since we are creating a /16 network, because I need 65,000 IPs, because 256 and it will be very less for me. So I'll use /16, which I'll get 65,000 IPs. I know it will be confusing, but it's very basic which I'm telling you. But yeah, This is how generally it is. So yeah, so CIDR block is this one, 10.10.0.0/16, which will get 65,000 IPs for us. And next thing is, there is some another IP address type called IPv6 CIDR block. So I don't need it. I mean, I won't be using for servers and all. Simply keep no. Next thing, tenancy. What is this tenancy is? You know, as I think I told you earlier, AWS share the resources among multiple customers. I mean, let's say one resource they'll use for multiple customers. So if you click tenancy as a dedicated, they'll have a dedicated infrastructure for you. Let's click on info if you don't know. See, you can run instances in VPC in a dedicated hardware. They'll keep it separately hardware for you, of course with extra cost obviously. But if you say default, it'll be what happens is it will be shared with other services. I mean, some other company also using the AWS, right? So they and we will be sharing it. Of course we don't know it, but AWS guys manage that in their data centers. Dedicated will be little cost. I don't need it, just for practice purpose. I mean, just click dedicated, that's it. No need extra setting and all. They will automatically separate it for you. They'll cost it for you. No need to do anything from your side. So there's no extra option. See, you can select dedicated if you want, or default. Just create a VPC. Your network is created. See, CIDR block. This is our network range now. So now we can run our instances in this VPC, in this network, in this VPC, call it, or network, both are fine. That instance will get this IP address. And of course, don't worry, still we have more to go. First thing, let's DNS host names. It's disabled currently. It means it can, let's say there is a DNS host name like abc.com something, it cannot resolve it because it's disabled. Let's edit it, VPC settings, enable DNS host name, that's it, and save it. Done. And if you see, DNS resolution is already enabled. So these two, make sure if you want to resolve your domain name, make sure this is enabled. That's it. Got it. So that's about creating a VPC. We just, the very first step, we created it. So next, so I created my network. Can I run the servers directly? No, not possible. Still we cannot do it. Why? Let's see. EC2. Let's go. Instance. See, yeah, there is nothing. Let's launch. Forget about the name. Go to network. See here. You can edit this. There are default network obviously, and this is your network. See, which you created VPC. Just select it. Shall I create? No. If I create, it will throw error because. Let's try. Let's see. Let's create it. See, it's throwing error. It's asking something called subnets. There is no subnets obviously. Let's see what are those subnets. These are called subnets. Of course, forget about this. These are default VPCs. Let's have what is subnet first. Let's see. So let's say I created my network here. If you observe, I created my network. This is my network, sorry. So this network is huge. 65,000 IPs are there in this network. Of course, I cannot use it at a time. You know what I do? I'll divide the network into smaller parts, and I'll use the smaller parts one at a time, maybe two at a time, as of my use case. Why I need to use it? I mean, I have network directly, I can use it, right? Yes, you can use it directly. Generally, I mean, not in AWS, but in normally in networking concepts, you can use it. But not a good practice, because you have 65,000 IPs and you're using huge network. So the IPs will be random between those 65,000. Of course, still it's in our network only, but it's random. Another thing is you're wasting your IP address unnecessarily here. 65,000 IPs, you maybe use 10, but remaining all are in use because you're running your service, you're using the network. So that's what I have is option. I'll divide this subnet into smaller parts. This is one network, 10.0.0, sorry, 10.10.0.0, one network. I'll divide them into even smaller parts. So what happens? I'll use the smaller part one by one. Remaining will be unused. So whenever I want, I can use them. So I'm not wasting here. That's where the concept comes, subnetting comes. The subnet like dividing our network into smaller parts. So why? So that we won't be wasting the IP addresses. So we'll be creating the network into smaller parts, and we use those smaller parts instead of using the network directly, which will waste the IP address. So let's say I divided the network into two parts. One part I'll use. One part will be unused. I'm not wasting it. So whenever I require, I'll use that part. Similarly like this. See, if you have a cake or something, you eat half, you'll keep the half in fridge, right? If you try to eat full, let's say imagine you have a round cake, you eat from the right side first, you eat from the left side, you eat from the right, front and back. You touched every part of your cake which no others can eat, right? See, no others can eat, obviously, because you touched everything. Now imagine the cake is there. You cut the cake into 8 pieces. You took your piece. Remaining piece can be used by others. Remaining, or let's say only you are there. Then also you cut your pieces. You take one piece. Remaining piece you keep in fridge, so that you can use anytime. You can eat them anytime later, right? Or if not like that, directly single piece cake you just put in hand directly in the middle. You don't get hard to eat it maybe next time. I'm just maybe a bad example, not a good example, but yeah, this is what we are trying to do. So we have a huge network similar to cake. We're dividing the network into smaller pieces, and we're taking one piece by one piece every time. So now this piece of cake is a part of a bigger cake, right? Correct? It's not outside. So the small cake, the piece of cake is part of a bigger cake, the one big cake which we took. Same thing here, subnet also we are taking from one piece of cake. Subnet is a piece of cake which we are taking from the main cake, the big one, from a VPC. It means the subnet, the IP, here we are getting subnet within the VPC. So the subnet is a part of VPC only, not outside. It means, let's create it. So when I told, let's select the VPC. Yeah. So when I told like part of VPC, when I told like we're dividing the network into smaller pieces, it means we are out of 65,000 IPs, I'm taking maybe 100 IPs. I'm taking maybe 1000 IPs at a time. Or I'm taking 10,000 IPs at a time, maybe anything. I mean, depends on your use case. So here you have to mention, sorry, yeah, here you have to do the same thing. Out of 65,000 IPs, take some and create that as a smaller part. So let's see how to do that. So subnet name sub1, I'm just giving like this. Which availability zone you want to create a subnet? Maybe 1A. So here if you see 3 are there availability zones, make sure you create these subnets. That will be good. Make sure, I mean, I'll explain that why we need to create in maybe in future further, but make sure you create in all 3 subnets. I mean all 3 availability zones. One subnet in each and availability zone. So for now 1A. And here IPv4 CDR block. This is the the VPC range. Now here subnet range you have to give. Subnet range you have to give. How many IPs you want for subnet? So now the number here, let's say 10.10 is common now. 10.10 10 dot. These two are fixed because we gave here, right, 10.10. The numbers are fixed, we can't change for subnet. Even for VPC also we can change, sorry. And the 0.0.2 zeros are there. These, in these, the third zero, the third C, the third digit, that we can change. That we need to give here. What is the range? 0 to 255. You can give anything. So anything you can able to give. Maybe let's say 50. I can give 50. So last last you have to give 0 obviously, because if you give other digit other than 0, it's an IP address. So like this you can able to give. So first two digits are fixed because VPC we have fixed first two digits. You cannot change that. If you have to give the third one, 10.10 dot whatever the number, the third column, third digit, don't say column, third digit from 0 to 255 for a subnet. Why? Because the subnet is a part of VPC. So within this range only we have to give, within this IP range only, because it's a part of VPC, right? That's why. So within this range means what is the third one? 0 to 255 I have to give. Let's say I'll give 189 or 183 as an example. Dot 0 is fine because not the last column should be 0, otherwise it's an IP address. Now count how many IP address will come. So now for subnet these three are fixed. Sorry, these three are fixed. So IP ranges will be the last column 0 to 255. It means how many IPs will come? 256 IPs including the 0. So for 256 IP range, the subnet ID is /24. That's how you create. Let's create. See, it's created. Let's create one more thing. VPC, my VPC, subnet, sub 2, availability zone, select 1B maybe. Now I'll give 10.10, it's fixed. If I try to give 183.0, it won't work because the network, so subnet is already there with 183. See, so you can't use 183 now. 0 to 255 you can use anything except 183 now. Maybe let's give 100, anything, your wish, anything. I'm telling you, right? There is no, see, sub 1 sub 2, these two. Let's create one more. Sorry, sub 3, sorry 3, availability zone 1C, IP. Okay, what is subnet range? 10.10.1 I want to give, dot 0 slash 624, sorry 24 IP. See, like this also you can give. I told you 0 to 255 range, it means 256 subnets you can able to create within a single VPC. They'll ask in this kind of question, how many subnets you can create within a VPC. So if you create a VPC with /16 subnet range, sorry, /16 class, sorry, don't say class, /16 subnet mask, we can create 256 subnets. Because why? Because in the VPC it will be here. Where is it? The VPC here. Yeah, in this VPC 0.0.0.0, sorry, 10.10.0.0 means the third column 0 to 255. It means including 0 to 56 subnets I can able to create. Got it? So imagine 256 subnets. Let's open the calculator. Sorry, I'm not good at math. So for a VPC you can create 256 subnets, and each subnet have 256 IP address. See the number, and let's see, that's how we calculate. See the number, all are same, and let's say /24. Sorry, my bad. 256 IP address. How they know 256 IP address? Because the last column, see here, the last column 0, 0 to 255. So 256 IP address optionally you will get like that. So now we can able to run our servers. So now we'll go to launch instance. Of course, VPC, my VPC subnet. Which subnet you want? Refresh. See which one you want to, in which subnet you want to create. So internally, what we did, we created one subnet in each and every availability zone. So you can choose based on which availability zone you want to run your instance. Choose that subnet. I want to run 1C. 1C. Choose the subnet 3. Because subnet 3 is created in 1C, EU West 1C, right, in that availability zone. So I want to run my instance in that availability zone. That's why I choose in that IP address. If you don't want it, maybe this one, you can select it. And of course, let me create a key pair. Create. So you want to enable the public IP address for this instance. Of course, we need public IP because we can't log in without public IP to EC2. So let's enable it. Security group, you have to create it. Firewall, you have to create some name. Security group will come, don't worry, later. Whatever SSH, okay, SSH is enabled. See, we can log in, and that's it. Let's create. Oh, let it create. Sorry. Alright, let's go to instances. See the instance. Public IP address is, it will come some random range. Observe the private IP range here. Is this our VPC, right? What is 10.100 is, I think, what is that subnet? Subnet 2. See, in this range only it came 10.10.100 dot, whatever the range 96 between 0 to 255. So this server is in our own network now, not in AWS default network. Got it? This server is in our own network now. So obviously, see the private IP address, private DNS name also will be there. You cannot log in by private DNS from internet because it's not possible as of now. So you have to use public IP address only. Let's log in. Let's log into server. Of course, let's see. I want to show you one thing. Blah blah blah. Go to downloads. Right click. Git bash. Paste it. Let's see. It won't log in. It won't log in obviously. Let's check the firewall whether 22 is allowed or not. So security. Firewall. Let's see the firewall. Obviously 22 is allowed, see, but still connection timeout. It won't log in. Let's try again. Let's see. It won't log in. That's obviously an expected output. See why it won't log in. Of course, we have the firewall is ready. Of course, we have our own network, but still we cannot log in. Why? You know why? Because there is no internet access to that server, which means there is no internet connectivity to your network. See, you have a Wi-Fi in your home, but obviously the Wi-Fi vendors, they'll come and they'll enable the they'll set the wire and connect to you, right? That RJ45 cable, I believe. So that from that you will get internet. Let's say you don't have that wire. When you just bought the Wi-Fi setup box and you just plugged in and switched on, will the Wi-Fi come? Of course, you can connect to the Wi-Fi, that device name based on the password and everything, but Do you get the internet access? I believe no. That's right. So you don't get the internet access. Why? Because there is no internet access. You just bought some, what is that? The router from somewhere shop, and you just plugged in. How you'll get the IP? I mean network. I mean the internet. Similar way here also. See, you created your own network. You created your own subnet. Okay, but how the hell internet comes to this network? Correct. That's where the concept comes called internet gateways and route tables. So these two are co-linked together. So internet gateway gives you internet access. To keep it simple like that, it will give you internet access, and the route table will decide how the internet should come to your network. Got it? First, where is the internet gate? Sorry, let's go to internet gateway. Okay, yeah, here it is there. Let's go to internet gateway. So internet gateway will give you internet access. To keep it simple, internet access. So create an internet gateway. It's actually a virtual device, we call it actually. So where we create this device, we use this to get the internet access. See it here. An internal gateway is a virtual router that connects a VPC to internet. See, that's what we want, right? We want internet access to our VPC, our network. So that's why in order to do that, we need an internet gateway. So something IGW means internet gateway shortcut. No need to do anything, just simply create internet gateway. That's it, it's created. Now all we have to do is you have to attach your this internet gateway to your VPC, because that's where you need internet access. Simply click on actions, attach to VPC, select your VPC. This is the one, right? Attach. See, attached. Now if you observe here, come back, your internet gateway which you just created now is attached to this VPC. It means, so this VPC will get internet access now. It got internet access. Okay, now ready. Internet access is there. Let's try. Still it will be same. Of course, with internet gateway we gave the internet access to our VPC, but still it does not know how to go to internet from my network. How it should go to internet? It does not know. Just imagine your phone also. If you open something, it will go to your Wi-Fi, it will go to your internet, and it will get back to you, right? Similar way here also, we have internet. Internet gateway gave you internet. I mean, you means your VPC obviously. Internet gateway gave network access, sorry, internet to your network, your VPC. But how it should go to internet from your network, and how internet comes to your network? That's where the route table concept comes. Route table is decides. See the description here. It decides how the internet should come to your network, and from how your internet should go to your network should go to internet. So here route table, obviously by the name you will get it. We will be creating some set of routes, some rules, how the traffic should flow from your network to internet, your internet to network. See here what we are trying. We are trying to talk to our server. I mean the traffic will be connected to server. So, but since there is no route how to go, it does not know. That's why we have to create a route table. We have to create a route table. Let's get test route table. RT means route table. Select a VPC. My VPC. Create. So by default this is one route it will come. What you have to do first thing is add a route, edit routes. So you have to add a route. What is the destination? Internet, right? Internet means 0.0.0.0. This is the internet address. So what we are doing now, we are creating a route from your network to internet and your internet to network. Through what? Through route table. By using what? Internet gateway. Because that's what gives you internet. Route table gives you routing. I mean the route, like a bridge, let's say bridge. So you have two cities. You know where the city is. You can see able to see it, but you can't go because there is no bridge. There's water inside it. You can't swim. With route table, we are giving a bridge. We are building a bridge here with the help of internet gateway. See, there are so many things. Choose internet gateway. Where is this? Yeah, see here, internet gateway. What is your internet gateway? See, this is the one we just created. Let's save it. Then see, one new route is there. Now, when something when we're trying to access the internet from within this VPC, it will go through this route table with the help of this internet gateway to internet. Similar way, response also will come back reverse like this. Got it? Let's try to access. Now it will work. Let's wait. Oh, sorry, I forgot. Sorry, one more thing. It won't work, obviously. Why it won't work? Of course, you may ask. Okay, we have a route internet gateway, which will give internet. Route table is there, where we created a route to internet. Zero dot the address. Still, why it's not working? We need to do one more small extra step. Here, if you see subnet associations, we need to associate our subnets to this route table. Then only the route will be applied to your subnets. Obviously, your server is running in the subnet, right? So, how the subnet know whether the route is there or not to the internet? Your VPC knows it. Your VPC know that there is a route table, there is internet gateway, the network route is there. But how the hell subnet knows it? Our servers are whatever we run in subnets only. So the subnet also we also make sure that the subnets knows the routing table. So simply we have to click on edits, subnet associations, select all these subnets, save association. We are associating the subnets into this route table which has the route. See, now it will work. Let's try again. See, the hell it is working now. As see, isn't it cool? Of course, if I remove these associations, it won't work. Obviously that's like it. So that's what about route tables and internet gateway. You can create internet gateway, just simple. Obviously you've seen it. Route table also you can able to create. But I wanted to tell you, when you create a VPC, we created a VPC, right? When we create a VPC, there will be default route table available. See, created automatically. So when we create a VPC, a route table also will be created automatically. See here, see here, see. You can use this route table also, completely fine. You can delete this, let's say which we created. Delete route table. I cannot delete because it has routes. Let me remove the routes. Sorry. Let me remove the routes. This is the route. Remove it. Save it. Remove the subnet associations also. Now I can delete this route table. What still? Yeah, sorry, I did to do. Delete. I told you there will be a main route table. There will be a route table which is created. See the VPC. This is the route table. You can give a name. My RT route table. So you can use this route table. No worries. No issues. Completely. I just showed you to create a new route table. That's it. Since this is already created as a part of VPC creation, you can add the routes. Go here, edit routes. Add a route to internet, right? To internet gateway, select IGW, this is the one. Save subnet associations, add your subnets into, associate your subnets into what is it? Into route table and try again, which will work. See, as cool as it is. So is it clear about this route tables and internet gateways? And of course you have seen elastic IPs already. is as elastic IPs are static IPs which will be assigned to your account. You can assign them to any servers only for EC2s. I mean, not for any other things. So these elastic IPs you can able to allocate address. So you can able to create. This is not part of any VPC because elastic IPs are public IP address, not part of VPCs. The public IP address will be random, some randomly generated. Got it? So that's about the network. Of course, it's not yet fully finished. We'll have 3 more classes, maybe 2 more classes. So there will be so many topics. For now, let's go to security. This security group, something like that. What are those? Let's discuss this. You already seen it. You already seen security groups. Let's click on this. As I told you, when you create a VPC, a default security group will be created for you. See, a default security group will be created for you for our VPC. This is which we created for EC2 mission. You can, I mean, don't use the default one. I mean, you can use it. There is no issue, but no one, many people skip the default one. Let it, they'll leave it, and they'll have their own security groups too. They'll use it. First, let's see what is security group. Of course, you know it about a little bit. It's a firewall. Yes, exactly. That is firewall. So security group is nothing but a firewall which will be assigning to our AWS services at a service level. So if you create a EC2, you'll assign the security group. Of course, you already seen it. I mean, no need to show it again. You can create your own or choose the existing one. And if you create a load balancer, you choose the security group. If you create a CloudFront, I think no, not CloudFront. Sorry. If you create a EFS, you'll assign a security group. So at a service level, you'll have your security group. So you can normally create here also. Whatever the name, blah 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 something, blah 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 something. Which VPC the security group belongs to? My VPC. And there are two things are there here in security groups: inbound rules and outbound rules. Of course, you know this. Inbound means incoming, outbound means outgoing. So incoming traffic and outgoing traffic, which one you want to allow? So obviously outbound is already allowed to everyone, so you don't need to add this. You don't need to modify anything here. So you have to add only inbound rules. It means incoming traffic. So you can add a rule. Obviously you want something to be accessed. Let's say I'm just now we have seen, we try to log into server using SSH, right? So we are trying to log in. So the request is going to the internet. I mean, so because outbound is allowed, it will go to internet. Inbound also should be allowed, so that internet can give you, internet can able to talk to you. So that's why we need to allow inbound rules. First thing, you can give any port number here, whatever you want. Let's say 80 or 443, or you can simply select here also. See, you can simply select SSH. It will change. Sorry, my bad. Let me change it. Let me remove. Why it is not going? That's okay. Let's see. SSH. See, the port will automatically come. Let's say HTTP. Port will automatically come. If you want to give your own port, simply choose custom TCP. You can give range also like this, 82, 10,000. Like this you can able to give. So between the range, so from 80 port number to 10,000 port number, we are allowing everything. I mean, we are allowing these port numbers, it seems. Or let's say you want to allow all the ports from 0 to 6, sorry, I think the port range is 0 to, if you observe, 0 to 65,535 range. If you want to allow all the ports, simply go here, all TCP. See, depends on your requirement, allow your protocol. Each and every protocol will have a port number. Obviously I don't need to say it again. So let's say this is what I want to allow, maybe HTTP. Yes, 443 will come automatically. You don't need to add it. If you want to default port, let's say Tomcat port 8080, right? So Tomcat won't be here in the rules because these are default rules, default available protocols. So Tomcat won't be available. You can simply custom 8080. You can keep it like this. You can see NFS, EFS, I mean NFS also. See MySQL also there, that we will see. Maybe LDAP, so many are there. DNS, like this you can able to give. So now first step is done. So you're following a protocol, let's say port number. From where? That's where we have to select the source. From where you are allowing this? We have multiple things. My IP means, sorry, not don't select my IP for now. Anywhere IPv6 means overall the internet. So if someone knows, if I mean anywhere means from anywhere or the globe, they can able to access if they know the IP address, because we gave access to 8080 port to the internet 8080.0.0.0. Of course in organization no one gives that, but I'm just for now I'm just saying this. Got it? Let's say you want to have custom, I mean maybe you want to have allow this port number to specific network, maybe your office network. You can give like that, maybe 10.10, maybe not this, don't use this, 192.168.0.0, sorry, dot 0/60. Maybe I'm just saying this is your office network, so you want to allow Tomcat port number in your office network. At that time you can choose custom and give it. See, you can give like this also. Or there is one more option called my IP, so where I can able to access from my IP address only. But what is this IP? This is not my IP, right? This is my public IP because I connected to internet. So this will be my public IP. Something, let's see. 4943. Where is it? Sorry. Here. Yeah, 4943 to 4200. See, come on, man. 49, 43, 200 something. It will come 243, 200. 242, sorry. Same thing here only you can see. So when you connect to internet, you'll get a public IP address. So you can able to use that. So here also, my IP means automatically the security group finds your IP address. Public IP address, not your laptop IP address, public IP address. Because you connected to internet, you will get a public IP address automatically. This will change, I mean, it's not fixed. Once you disconnect your network and connect again, it will change obviously. So like this, you can able to access only from IP, this is my IP address. Let's allow maybe ping, I can, so that we can test it. Ping protocol, IMAP. Wait, where is there any other thing? Not IMAP actually. These are different. ICMPS. This is a ping protocol. So you can, if you let me allow from all. Now what happens? Sorry, not here. Let's go to EC to change this one because we want to test it, right? I'm just editing inbound rules. You can edit anytime, no problem. There is no issue. ICMP is for ping. The ping protocol is ICMP. So I'm allowing everyone. So if you, I think you might have opened your login from your laptops. Let's try to ping. So I'm getting reply. Try from your side also, please. This IP address 63.32.93.131. Try from your side. Anyone, try it and let me know the result.
From local command prompt.
So, yeah, from local command prompt. Just ping command. Ping works anywhere.
I'm getting request timeout.
Request
I'm
timeout.
sorry.
Check the IP address.
Yes, I can.
You can able to connect, right?
Yes.
Because I allow to internet. Say 0 dot all can able to ping my server. Let me change it. Let me change it. Let me keep it to only my IP. So now let's try. I can able to ping because I allowed my IP address. See here. Now you try.
request time.
Because I blocked you. I mean, not blocking you. I just allowed only myself. That's why I haven't allowed any other. I allowed only myself, my IP address. See, that's why. Like this, you can able to block anyone. I mean, if you don't want to give access. That's how. That's how the firewall works. So if you, let's say here, I haven't added any rule for HTTP, right? 80 port number is not allowed, and 443 is not allowed, NFS is not allowed. It means you cannot access this server, whatever the server it's attached to, on 80 port. It won't work. By default, all are blocked except these two, 22 and ICMP ping protocol. Ping does not have any port number, so we just use the protocol. That's it. So like this. So this is one of the firewall. So which will be, and again I'm telling you again, which will be at service level. And there is one more firewall which we have never used as of now. So where is that? The firewall will be NACL, network ACLs. This is also one of the firewall. Of course, this is also default. When you create a VPC, an NACL will be created for you. Network ACL. This is also firewall, same thing. Same like in security group, NACL also firewall. This is the very common question in interviews. They'll ask, what is the difference between NACL and security groups? Some people call it a knuckle. I don't know why, but yeah, knuckle they'll call it. NACL we simply just to say. What is the difference between NACL and security group? The first, there is no first is both work same. Both are firewalls. There is no difference in that. This also works the firewall only. The first difference is it NACL will be applied to subnet. Let's say here test NACL VPC, my VPC, create. Where is it? NACL is created. See. So NACL will be subnet, will be work with subnets, not with service level. So which means, let's say now your server will be in one subnet, right? So security group assigned to your server, and this NACL will be assigned to a subnet, which means the NACL will be applied to your server also, because the server is inside a subnet. Correct? Let me draw the diagram. I'm not good at drawing, but please. So let's say this is my EC2 machine. Yes, EC2 machine. Of course, here we have security group for EC2. Correct? You have seen it. Now there is one more firewall called NACL. This is subnet. Imagine this is subnet. Subnet has NACL. Sorry, NACL. It's not Nexel. Sorry, CL. Sorry, NACL. So let's say I have one more server. I have one more server, one more server, one more server, one more server, one more server. Each and every server which have its own security groups. I mean, you can choose the same security group for all the servers. There is no issue. So what I'm trying to say is the difference. Security group comes at a service level. For each and every service will be having this, will be attaching the security group. But NACL will comes at a subnet level. So these servers, all the servers are in a single subnet, which means the NACL will be applied to all the subnets. That's the main difference. The first difference. They'll ask it, what is the difference between? First thing you'll say is NACL will comes at a subnet level. Security group comes at a service level. It means for individual service will be attaching the security group, but NACL comes at a subnet level. All the services which are running in the subnet, NACL will be applied to them. That's the first thing. So how you have to do? You have to associate the subnet. See here. Go to subnet associations. Associate any subnet. I mean, does not matter really. You can select all. Or can you have separate subnets? Sorry, separate NACL for separate subnet. That is completely fine. Save it. See, now it's associated. See the subnets. So NACL will be applied to all the subnets. Whatever the rules, firewall rules we give in NACL, all will be applied to these all the subnets, whatever running inside it. That's the first difference. Second difference. Second difference is, of course, we have both inbound and outbound rules. But by default, in security group, what we did, let's go here again. Outbound is already allowed. We did not add anything. It's already allowed to internet. We have only managed inbound rules in security group. We only manage inbound rules in security group. But in NACL, it's not like that. We have to add both outbound rules and inbound rules. See, outbound is blocked by default. So we have to add both. If you want to allow, if you want to access internet and internet want to access you, you have to add both here, both rules. Let's say I just added inbound, add new rule, this SSH, maybe anywhere allow. Sorry, this rule number we have to say, but yeah, that's okay. So maybe let's see this now. So NACL, let's create it. Let's save it first. So I added inbound rule SSH, which means internet can able to access my server. I mean, whatever my subnet, wherever we assigned with a 22 port. But I cannot access the internet with 22 port because outbound is not allowed. So you have to add outbound also. That is one. That is one rule. Sorry, one maybe 22. Select like this. You have to add both inbound and outbound. That's why we call NACL as stateless. So that's one difference. Second difference, sorry. So in security group we have to add both inbound. In security group you need to manage only inbound rules. Outbound is already added. But in NACL you have to add both inbound and outbound rules. And that's the second one. Third one is, let's add a rule again. Hopefully you might have observed now there are some rule numbers. So you have to, in NACL you can give some rule numbers. It will filter them by priority. So rule number 1 means highest priority, 2 means second highest. Let's say you can give like this also, any rule number. So that will be last priority. Based on the number, it will get the rule will get a priority. So in security group there is no such thing as rules. It's random. We just add whatever we want to allow. That's it. So there is no rule numbers. So here we can have rule numbers. So we can simply set the priority. Sort by rule numbers. See, like this. Of course, this does not have rule number. Let's remove it. That is one. In NACL there is rule numbers where based on the rule numbers the rule will get a priority. But in security group there is nothing. There are no rules. It's just random. That's the third difference. The fourth one is, see, observe on the right side, allow or deny. In NACL we can block something and we can allow something. Both are there. But in security group, if you observe, go here, there is no blocking. By default all are blocked only. You are just allowing. See, HTTP is blocked as of now. If you allow only HTTP, it will come here. It will be allowed. So where is it? It will be allowed. If you don't allow it, it is blocked by default. That's how. So there is no blocking feature specifically in security group. By default all are blocked. There is only allow feature. But in NACL there is something called allow or deny. Both are there. You can block something. Of course, if you don't allow it, if you don't add a rule, it will be blocked by default. But this advantage also is there where you can add a rule to specifically block something with deny. Let's say rule number, obviously I'll give 0. Yeah, sorry, I can't give 0. Let's give 3. Maybe telnet. Let's remove this rule. Telnet, I'm blocking it. So incoming traffic will be blocked for this telnet. So when internet try to access the telnet, something, whatever it is, it will be blocked because we are specifically blocking it. Let's save it. See, we're specifically blocking it. By default all are blocked. If you observe, there is a default rule, all are blocked. You cannot change that. If you just simply edit it, see, you can't see the rule. See, it's you can't edit it. See the last one. So you have to allow the rules. So that's the last difference between NACL and security group. Of course, don't forget, you have to add outbound also. If you want to add inbound, if you add inbound, you have to add on outbound also for that same protocol. So that's the four differences. Sorry, NACL security group. See, let's open a photo. Maybe this one. See, operator instance level, service level, operator subnet level, NACL. This is. Let's open this website. This blog. This guy is good. So first one is security group, second is NACL. Let me know if you can see this. Can you see it now? So first one operates at service level, I mean instance level, because we attach to instance or load balancer or something. Operates at subnet level, NACL, we have seen it. Second instance, same thing. Apply to an instance only if it is associated with an instance. Apply to all the instances deployed in associated subnet, because because it's operated subnet level. So you don't need to attach this NACL separately to instances. It will be applied automatically. In security groups, it's only allow rules only, because by default all are blocked. You only have allow. But in NACL, allow and block both are there. You have seen it just now. And of course, if you see here, in security group, all instances are evaluated before deciding whether to allow traffic or not. Because based on whatever rules we added, so everything will be checked, obviously. Here also everything will be checked, but in order, because of the rule numbers. You know the rule numbers, right? We have seen it. So that will get the priority. So it will be starting with the lowest rule number. It will check each and every rule based on the rule number, and it will decide whether to block it or not, allow it or not, like this. That's why security group is stateful, because inbound outbound is already added. See here, return traffic is allowed regardless of the rules. That's why we call it security group is stateful. NACL is stateless because we have to add both rules, inbound and outbound both. That's why. That's the difference. So very common question generally asked. Of course, once you start practice it, you'll know it, the understanding that, but I'm just saying it. So that's about the firewalls in AWS. We have, in VPC. There is, yeah, in VPC. Security group and NACL. So mostly, people manage security groups. NACL will manage later. Whenever they want to allow specifically only something, whenever they want to allow something, but both things they'll be using. Now imagine this is the scenario what I told. So when a traffic comes, imagine now, let's say traffic is coming on maybe 80 port number from internet. Let's say arrow mark, where is this? Yeah. Traffic is coming on HTTP 80 port number. Traffic is coming here. So what happens? First it will talk to NACL, right? Because it's on the subnet level. First it will talk to NACL only. If NACL allow the traffic, then only it will go inside it. Then it will talk to EC2, the security group. Now here, if the security group is blocking the 80 port number, it's not, if the security group, if they say there is no rule of 80, the traffic is blocked here. It will be blocked. So that's how it works. Even though NACL is allowed, but security group is not allowing. So it will come inside subnet, come at instance, but security group is blocking that because there is no rule for 80. It will be blocked. Or let's say security group 80 is allowed, but NACL is blocked. So that traffic will be blocked at NACL level. So both has to be allowed if you want to receive the traffic, send and receive the traffic. If any of this is blocked, it won't work. Got it? That's how it works. Both has to be allowed, otherwise it won't work. So that's about the firewalls. So I think that's it. That's enough for today's class. So hope it's clear. What is VPC, subnets, internet gateways, why we use them, route tables, and of course firewall security groups and NACL. We have few more topics which are very important. Maybe if you are okay, we can continue. We can have a class today at 8:30 p.m. So what do you think? What do you say? We can close this.
Okay.
So we have something called a NAT gateways. We'll see that, and something called where is this? Blah 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 blah. Transit also one thing we can able to figure out this thing, and of course this also. Yeah, very small topics. Two to three are there. We can able to close it maybe today. So if you are okay, let's connect at night 10. Sorry, 8:30.
8:30 is fine for me.
Okay.
Others, I am fine with 9 also. No problem. What do you think?
Yeah, we can
Yeah,
connect at
fine.
8:30.
8:30 is fine.
8:30. Yeah.
All right then. So let me know if my voice is still not clear. So I'll try to do something. So yeah, have a nice day. I mean, happy Monday. I know Mondays are not happy, but happy Monday. Let's meet today at 8:30 p.m. Bye all.
Sure. Sure. Bye.
Bye.
Thank you.